Everyone, I'm going to quickly explain Euclidean geometry, but specifically similar triangles and congruent triangles. Now, for us to have an understanding of this, we need to visualize everything. So, just to shoot straight to similar triangles, so it says if two triangles are similar or equiangular. Now, what does this equiangular mean? It means as you look at angle A is the same as angle D. Angle B is the same as angle E, and angle C is the same as angle F because I use the dot, a plus sign, and an asterisk. Now, what does this mean? It means the angles are equiangular. It means the angles are equal. It does not necessarily mean the shape is the same. As you can see, ABC is bigger than DEF. So similarity has absolutely nothing to do with congruency. Congruent, it means they are exactly the same, but similar, it means they are not. Now, there are two ways to prove that two triangles are similar. Number one is by proving that their angles are equal, meaning they are equiangular. Number two is by using ratio and proportion, or they are in proportion. So it says, as it continues, then their corresponding sides are in the same proportion. What does this mean? If triangle ABC is similar to triangle DEF, it means the side of AB all over DE must be the same as BC all over EF and AC all over DF. Now, I'd like you to notice the pattern. It is AB all over DE. Look at both triangles. It's AB all over DE. If I choose BC, I have to choose EF. Right? If I choose AC, I'll definitely have to choose DF. We'll do this using an example. So, how are we going to use this? I want to use this example here. Okay, now this example says, prove that triangle QRS is similar to triangle UTS. Now you can see that QRS is quite smaller than UTS. That's expected. We are not expecting them to be congruent. We're expecting them to be similar. The sizes does not matter. However, it is important that you notice that the pattern is the same. What do I mean? If I'm going to say QR, right, I'll definitely have to say all over UT. Please note the pattern. It's written triangle QRS and triangle UTS. It means the first two letters, they have to correlate. So it means QR, it has to be all over UT, and then RS has to be all over TS, and then QS all over US. What do I mean? Let's quickly see. I've written them down for you like this. So you can already see that QR all over UT must be equals to RS over TS, which is equals to QS over US, and I find that is 1 over 3, but that's not important. That's not what we are answering now. We need to answer question 6.1. Let's go back to 6.1. Now 6.1 wants us to prove this. Now, can we use ratio and proportion? Let's see. I only have 10 and 30 at the moment. I don't have anything else. I have 6 centimeters. Will that help me? Now, this is what you need. You need 3 things. Right? You need 3 things. So let's go and plug in and see if this will help us. Okay, so I'm using proportion first. Remember, I'm not using equiangular. I'm not looking at equiangular. That might be another possibility, because remember, for you to prove that two triangles are similar, you either use ratio and proportion, as I've shown you with these fractions, or you use equiangular. You must show all their angles are the same. So let's first try this proportion first. Okay, so I have QS, which is 10, and I have UT, which is 30, and I have RS, which is 6. Let's quickly go back there and plug them in. QR is 10, UT is 30, RS is 6. So I basically have 10 all over 30 here, and then RS I'm told that it's 6, and I have TS. So clearly I'm stuck, right? I'm stuck. I cannot go further. I do not have QS I do not have US. Let's quickly go back and see if we can solve anything else. So we have 10, 6, and 30, and SU is X. That's all we have. SU is X. SU is X. So this means we basically have 10 over 30 equals to 6 over TS, and QS we do not know. I have US, which is X, right? So what we can do is that we cannot solve this at the moment. So we actually need to first solve 6.1. I hope you can see that we cannot use ratio and proportion here. We need to use equiangular. I hope that makes sense. Let me see how far I've went. Okay, no problem. Let's quickly answer 6.1. Let's go back to the question. Let's see the question. So we can clearly see that since we are told that QR is parallel to TU, we can use what we call FUN. I think you guys know corresponding angles, coincident angles, and alternating angles. I think I've done that with you. Okay, if you do not have any of the videos, let me know. I'll send you the videos. Okay, so we are going to do, we know that QR is parallel to UT, so it means angle R will definitely be the same as angle T, and they're going to be alternating. And then now we have that S1 is equals to S2. They are vertically opposite, or they are both 90 degrees. It leaves us with angle Q and U, which is, they have to be the same because the third side of the angle. Then it means these are equiangular. So what do I mean? Let's quickly do it and write it down. Okay, so I have R and T. So I'm going to say in triangle in QRS, triangle QRS. You know what, let me try writing, let me just put them side by side and let's see if I can write. That's perfect. So this means here I would have angle R, so I'm basically talking about in triangle Q. You don't have to write in triangle, guys. I just want to show you QRS and triangle QRS UTS. So I'll say angle Q. Remember, you don't need the statement. This is just for me to show you which triangles we are referring to. So I will say angle R, it is definitely equals to angle T, and my reason, these are alternating angles, meaning they draw a Z or an N, right? And I must always mention the parallel lines. So QR is parallel to UT. Very important, guys. Okay, so we have one angle done. Another angle, it will be S1 is equals to S2, which is equals to 90. They're both equals to 90, and we can say these are given. We can just see they are given. So this means, therefore, it means angle Q will definitely have to be equals to angle U, because it's the third side of a triangle. It must be equals to that, definitely, because it's the third side. Okay, so what does this mean? Therefore, we have proved that, because remember, we've proved that they're equiangular, right? We've proved that all the sides are equal. Therefore, we can say triangle Q, triangle QRS is definitely similar to triangle UTS. I hope that makes sense, guys.